All right, today we are going to take our knowledge of systems of equations and kick it up to the Algebra 2. So we have reviewed the Algebra 1 level of solving systems by graphing, by substitution, by linear combinations. Now we are going to take that information and apply it to a new concept, which is solving systems of equations that are in 3 variables. Now, I could read you through these steps at the beginning, but the steps aren't going to make sense until we actually apply them to a specific example. So as I go through these 2 examples here, I'm going to go through the steps one by one to come up with our 3 by 3 solution. So, a system of equations in 3 variables. You can see obviously in example 1a that I have 3 variables in my 3 equations. So I have x, y, and z. Now, on occasion you will have problems where maybe one of the equations only has 2 variables, and if that's the case, that should actually save you some steps. So if you run across that, that doesn't mean that it's harder. That actually should mean that it's easier because you have a little bit less work to do because you've already eliminated a variable from one of the equations. So these have all 3, so that means we have to go through all the steps for these. So the first thing we need to do is decide by looking at all 3 equations which of the variables is easiest to get rid of. So if I look here at A, on my x's, I've got x, 2x, 5x. So, I mean, they're not multiples of one another, so here the 2 and the 5 would be kind of a problem. I'd have to go maybe up to 10 to be able to get opposites on those. So let's look at the y's. The y's, again, they're okay, but since 3 is not a multiple of 2, I'd have to go up to 6 to be able to eliminate those. So I'm going to look at the z's. These, I see that these 2 are opposites. They both have coefficients of 1 here and -1 here, so those are already opposites. And the 3, well, I can get to 3 from 1 easily by multiplying. So I'm going to choose the z because it's the easiest one to get rid of. Now, if you choose the one that's not the easiest, again, that doesn't mean your answer is going to be wrong. It just means that your steps might take a little longer because you've got a little more complicated equations to deal with. So I decided which variable was easiest to eliminate. So check on that. Now I need to pick 2 of the equations and eliminate that variable that I chose. So here I'm going to eliminate z. And first, I'm going to choose equation 1 and equation 2. This work gets really long. These problems take a while, so you need to tell me by labeling which equations you're using. So I do that this way. I say I'm choosing equation 1 and equation 2. So these 2 equations, I'm eliminating z. And if you want to write out that you're eliminating z, that can maybe help you if you go back to try to find mistakes. You don't have to write that, but you do have to write which equations you chose. So I'm going to eliminate z from those 2. So I'm going to copy them down. Because they're already opposites, I don't need to change them any. So just copy them how they are. And because they're already opposites, to eliminate the z, I just have to simply add straight down in my columns, just like I always do with linear combination method. So x plus 2x is 3x, 3y plus y is 4y. My z's cancel, and -11 plus 1 is -10. So that step was in red. That gives me my new equation 1. Now some of you can keep that straight. Some of you might actually need to label that new equation 1. It's just a matter of how probably neat and organized your work is. If your work is not neat and organized, you might want to label it so that you're going to have to be able to come back and find that later. You don't want to have to keep searching. Next step. pick a different pair of two equations. So I already picked 1 and 2. I have to pick a different pair. So I can pick 1 and 3. I can pick 2 and 3, but I can't pick the same ones. The key is I have to eliminate the same variable. So I eliminated z. So now when I pick my new pair, I need to eliminate z again. On this one, I'm going to choose to do this time equation 1 and equation 3. Here's why I chose those. And again, you might choose something different. I chose those because this is already negative and this is positive. So I don't have to multiply by a negative. I find that multiplying by positives generally results in fewer errors than multiplying by negatives. So I need to tell myself which equations I chose. So I'm choosing equation 1 and equation 3. Now, they are not already opposites. Again, in order to get opposites, I have positive 3 here. I need to get negative 3 here. So that means I need to multiply that whole first equation by 3. I indicate that by writing a 3 in front of my circled equation number. That tells me I took 3 times equation 1 with equation 3 just how it was. So I'm going to do that. I'm going to multiply, and I should probably scribble this out so it doesn't look like a negative. So I'm going to multiply 3 times the first equation. So 3 times x is 3x. 3 times 3y is 9y. 3 times negative z is negative 3z. 3 times negative 11 is negative 33. So now equation 3 is my second equation. That's down here. I do not have to do anything to it. I can copy it just as it was. So 5x minus 2y plus 3z equals 21. So again, you have to eliminate the same variable. So I had chosen z before. I'm choosing z again. The z's are going to eliminate. When I add them, 3x plus 5x is 8x. 9y minus 2y is 7y. My z's cancel out. Negative 33 plus 21 is negative 12. This, as it says up here, gives you what we're going to call new equation 2. Again, you don't have to label these. If your work is neat and organized and you know you're going to be able to find it later, that's fine. Oops, and I just labeled that new equation 1 when really it's new equation 2. We go. All right, so I'm done with that. I eliminated the same variable. I have new equation 2. Now it says to solve the system of new equation 1 and new equation 2 using linear combinations. So what this is essentially telling me is now I'm back to an algebra 1 problem. What I just did got rid of my z's. I only have x's and y's left, so I should know how to solve any 2 by 2 system. So you may want to write them underneath each other, so I'm going to copy this one underneath over here so we can look at them together to decide how best to go about solving that system. So if I want to solve it, I need to get opposites. So if I want to eliminate the x's, I would need to get, since 8 is not a multiple of 3, 8 times 2 is 16, which 3 does not go into that evenly. 8 times 3 is 24, which 3 does go into 24 evenly, so I could do that. Or I could do a 7 and a 4 to eliminate the y's. I'm going to go ahead and eliminate the x's. It doesn't really matter which. So I'm going to multiply this top equation by 3. If I do that, that's going to give me 24x. So that means down here I need to get negative 24x, which means I'm going to need to multiply this bottom by negative 8. So when I distribute that, distribute my 3, 3 times 8x right here is 24x. 3 times 7y is 21y equals 3 times negative 12 is negative 36. Now the bottom, negative 8 times 3x is negative 24x, so that does give me my opposites. negative 8 times 4y is negative 32y. And then negative 8 times negative 10 is positive 80. So add, my x's are going to drop out. 21y plus negative 32y is going to give me negative 11y equals, and negative 36 plus 80 should give me positive 44. So now divide by negative 11. You should get y equals negative 4. I'm not done with this step here yet because I haven't solved the system if I only know one of the variables. I need to find the other one. So if y is negative 4, I go back to one of my new equations, the one that only have two variables, and I'm going to plug negative 4 in for x. So let's plug it in, let's say to this one. So 3x plus 4 times negative 4 equals negative 10. So 3x minus 16 equals negative 10. So to get x alone, add the 16 to both sides first. So when I do that, negative 10 plus 16 is 6. Divide by 3, and x is 2. So I have solved the system of new equation 1 and new equation 2. So that means I know two of my variables. I know x and I know y. Now we're back to something that is algebra 2, because now that I've solved that 2 by 2 system, I need to plug both of those variable values into one of the original equations. That'll allow me to solve for my third variable. Again, it doesn't matter which of the originals you pick. I'm going to pick the second one because it has the smallest numbers. So when I plug that back in, 2 times x, which is 2, plus y is negative 4, plus z equals 1. So 2 times 2 is 4, plus negative 4, plus z equals 1. These cancel, those give you 0, so z is 1. Final step, list your solution as an ordered triple. X's come first, then y's, and then z's. It's alphabetical order. 2, negative 4, 1. Really, really important on these 3 by 3s that you plug it back in to check your work, because that ordered triple has to work in all 3 equations if it's going to be a solution. So double check your work to make sure that you have it right. Whew! These take a while, huh? So we've got one more to do. I'm going to walk through these steps again, and this is going to take a little bit of practice, so you may have to do some extra ones on your own. All right, so let's take a look here and start with our red again. So first, look at them, decide what variable's easiest to eliminate. On my x's, these are already opposites, and this is pretty easy to get, so I could do the x's fairly easily. The y's I could also do fairly easily because these are already opposites and I would only have to multiply by 2 to get this. The z's are definitely harder. We don't want the z's. X's and y's are probably equally easy in this case, but I'm going to go ahead and choose the x's just because they're smaller. They have smaller coefficients. So first, once I've decided what variable to eliminate, so I'm eliminating x first, I'm going to choose my 2 equations to start with. So I'm going to choose 2 and 3 this time because they're already opposites, meaning I don't have to multiply by anything. All I have to do is copy them down and add them. So x minus 6y plus z equals negative 4. And negative x minus 3y plus 8z equals 1. So add straight down. My x's are going to cancel. On y, negative 6 plus negative 3 is negative 9y. Z plus 8z is 9z. And negative 4 plus 1 is negative 3. So I've got negative 9y plus 9z equals negative 3. So this is my new equation 1. Remember that we need these equations because we're eventually going to solve the system of the 2x2s. Alright, so next, I eliminated one variable with one pair. Now I need to pick a different pair and eliminate the same variable. So I'm still eliminating x, but I can't pick 2 and 3. I need to pick something different. Here I'm going to pick 1 and 3, again, because this one's already negative, so I can multiply by a positive. So I'm going to pick 1 and 3. Now, because they're not already opposites, I have to multiply that third equation by 2 to get 2x and negative 2x. So I indicate that I'm multiplying the third equation by 2 just like this. So the first one staying how it is, so recopy it, 2x plus 3y plus 7z equals negative 3. And when I multiply this third equation by 2 everywhere, negative 2x minus 6y plus 16z equals 2. Again, this equation came from multiplying 2 times this equation. 2 times the negative x, 2 times the negative 3, 2 times the 8z, 2 times the 1. Okay, so add straight down. That will eliminate my x's again. My y's, 3 plus negative 6 is negative 3, so negative 3y. 7z plus 16z gives me 23z. And then negative 3 plus 2 is negative 1. All right, so that is my new equation 2. So you can't try to memorize, I do this and then I do this. You need to memorize the big picture. The big picture is, first you need to eliminate one variable from 2 pairs of equations. That is going to get it down to a 2x2 to solve. Once you have that, then you're going to plug into the original so that you can find your third. That's the big picture. So what I've done of the big picture here is I've completely eliminated one variable from 2 pairs of equations. Now I have a 2x2 that I can solve. So here's one equation, here's the other. I need to solve that system. So it's easier to write them underneath each other. So I'm going to take new equation 1 and write down underneath new equation 2 so that I can look at them and decide what is easiest to eliminate, the y's or the z's. Well, 23 is prime, so that's not a really good number. So we're going to eliminate the y's. And you need to ask yourself, what can I multiply negative 3 by to get the opposite of negative 9? Well, the opposite of negative 9 is positive 9. So if I want to get positive 9 here, that means I need to multiply this top equation by negative 3. So I'm going to write that in purple, negative 3. So distribute it to all 3 terms. Negative 3 times negative 3y is positive 9y. Negative 3 times positive 23z is negative 69z. Negative 3 times negative 1 is positive 3. So now I've got opposites on my y's. Add straight down, those cancel. 9 plus negative 69 is negative 60z. Negative 3 plus 3 is 0. divide by negative 60, z is 0. Remember, when you get 0, I always have people who say, oh, no solution, I got 0. No. No solution is when the variables actually drop out. Your variable didn't drop out. Your z is still there. The value of z is just 0. So take that 0, plug it back into one of your new equations here, doesn't matter which one, and find y. So if I plug it into this one, negative 9y plus 9 times 0, which we know is 0, equals negative 3. So a plus 0 we don't really need. So divide by negative 9. Be careful here. Negative 3 divided by negative 9 is not 3. The bigger number's on the bottom, so that means this is 1/3. So y is 1/3, always fraction form. So z is 0, y is 1/3. Now, I eliminated one variable. I solved a 2 by 2 because I know 2 of the variables. Now, plug both those into my original to find my third. So I'm going to go back to my original. Doesn't matter which original you use. I'm going to use the second one, I guess, smaller numbers. So I'm going to use this equation, and I'm plugging in x is what I still don't know, x minus 6 times y. Y is 1/3, so I put that in, plus z, which is 0, equals negative 4. So negative 6 times 1/3 is negative 2, plus 0 is just nothing, so equals negative 4. Add 2 to both sides, and x is negative 2. So x is negative 2, y is 1/3, and z is 0. So ordered triple, negative 2, 1/3, 0. Now, I put here, don't forget how to recognize systems that have no solution or infinitely many. This hasn't changed just because we're doing a 3 by 3. You will proceed with the steps like you always do. At any point, it could be in the solving the 2 by 2, it could be when you're first trying to eliminate a single variable. But at some point, if your variables all drop out and you have a false statement, that means it's no solution. If your variables drop out and you have a true statement, that's when it's infinitely many. Make sure that you still remember how to identify those. And that is it for this lesson.